Welcome to today's lesson on graphing sine and cosine. We spent the last several days going over all of the properties of the sinusoids and how the period, amplitude, phase shifts, and vertical shifts can affect transformations on the graph. At this time, it's time for learning targets 4 through 6, which are describing the transformations, determining the order they go in, which we've been practicing, and then we're adding in learning target 6, performing the transformations and graphing all of the sinusoidal functions. So at this time, we're going to start graphing all of those functions that we've been learning about so far. For graphing sine and cosine, you've got several steps. First, identify the parts of each equation. Make sure that you factor out the coefficient of x before you identify the phase shift. That's only if there are B and C. Only when there are B and C. Number 2, describe all the transformations. Include reflections, horizontal and vertical stretches, phase shifts, vertical shifts, all of the things we've been practicing. Make sure that you put them in the order in which they must occur, because now that we're actually performing them on the graph, we need to make sure we're doing it in the proper order. Start off by graphing the original function so that you have a reference point. That's step 3. And then step 4, to sketch the graph, do it one transformation at a time. To do reflections, take each point and reflect across the appropriate axis. Any points on the axis you're reflecting over are going to stay the same. To do vertical stretches, you would multiply the y value by the stretch factor, because vertical goes with y. So for example, a vertical stretch of 3 is going to make a point now move from a y value of 1 to a y value of 3. For horizontal stretches, you're going to multiply the x value. Horizontal goes with x. So multiply by that stretch factor. A horizontal stretch of 2 is going to make a point that had a horizontal value of pi over 2 into a new horizontal value of 2 pi over 2, or pi. To do any phase shifts, move each point over either left or right the appropriate amount, and to do vertical shifts, move each point on the graph either up or down the appropriate amount. What I want you to notice is that in each one of these steps, it's making sure to emphasize that you're moving points. Move each point. Move each point. Make the point. The point. The point. So you want to use the points of your original graph as your reference and use those as you go through your steps. We're going to start off with some pretty basic examples and then work our way up. So we are going to start off with y equals 3 cosine of x. The 3 value out front represents an a value. A changes amplitude. Amplitude should be the absolute value of that. So it's going to make it a 3, which is going to be a transformation of a vertical stretch times 3. Okay, so we start off there. Since the b value is a 1, there will be no change in the normal period of 2 pi. Since there's no c value, there's no phase shift, and since there's no d value, there's no vertical shift. So you're going to start off by graphing the original function. Okay, so cosine starts at its maximum, and then it goes downhill, back uphill. Notice that we're graphing point by point so that we have all of our cosine curve to connect. I'm going to use a dotted line since I only have one graph so that we can draw the original cosine value. Then we take each y value and multiply it by 3, which is going to make a y value at 1 become a y value of 3. A y value at 0 stay a 0, and any y value at -1 become a -3. Go through and add in each one of those points one by one. Then you'll get your new cosine curve with a new amplitude of 3. I'm going to use a solid line so that I know it's my final answer. As you're doing this with pencil on your own, make sure that it is clear the distinction between the dashed lines that are the original and the solid lines that are the new answer. Okay, example 2. Sine of x minus 1. We start off with amplitude. Since our a value hasn't changed, we're going to have an amplitude of 1, like normal. Since we don't have a b value, our period stays the same, like normal. We don't have a c value, so we have no phase shift, but we do have a d value, the very end of -1, which is going to move it down 1. So transformation-wise, all I'm doing is moving down 1. So I start off with my original sine curve that crosses at 0, 0 and goes uphill, then back down. I'm going to draw this original sine curve with a dashed line so that I know that it's my original curve to reference from. Then I'm going to take each point on the graph and translate it down 1. So point by point. We move the point at negative 2 pi down 1. We move the point at negative 3 pi over 2 down 1. We repeat this process all the way across. We're going to connect those dots with a solid line so that we have our final graph of sine of x minus 1. Make sure that as you're drawing these curves, they are true curves. It is one of the inclinations of many students to make them into V's, and these are not straight lines connecting the dots. So you need to make sure that you are not connecting with straight lines either. They should be a nice curve and arc to each one. Okay, the next one is sine of 2x. This time we have a b value inside. So that b value is going to affect our period. But our a, we have no c, and we have no d. So we have no phase shift, no vertical shift, an amplitude like normal of 1. But our period we need to find by using our formula. Period is 2 pi over the absolute value of b, which in this case is 2. 2 pi divided by 2 is going to reduce to pi. So I now know that my period is pi. Well, what does that mean about my function? It means a horizontal shrink times 1/2. Remember that horizontal stretch or shrink factor is the reciprocal of b. So 1 over 2. So it's going to shrink by 1/2. I'm going to start off again with my normal sine curve. So going through the origin at 0, 0 on the upswing. Draw that as a dashed line so that you know what you're referencing from. Then each horizontal value is going to be multiplied by 1/2. So it's easiest to start in the middle. 0 times 1/2 is still 0. So you've got a point still at 0, 0. At positive pi over 2, you multiply by 1/2, you get positive pi over 4. Your graph at 2 units away is now going to become 1 unit away. Your graph at 3 units away is going to become 1.5 unit away. So you take each point and essentially move it halfway toward the origin because your horizontal values are changing by 1/2. Once you get a pattern rolling of one wave, you can kind of continue that pattern on. You don't really have to do the math for really much of the rest of it. Connect those dots with a nice smooth curve. I know it gets difficult when they're this close together. Connect with a nice smooth curve and you'll see that you now have a period of pi. You have one full wave completed in pi. And you end up with 4 curves connected here instead of just the normal 2 that we would see in that normal 4 pi window. Okay, the next one, we have multiple transformations occurring. We've got an a value out front and we have a d value at the back, which is going to leave our period the same and no phase shift. However, it is going to cause a vertical shift up 2 from that d, and it's going to cause our amplitude, well, since we have a negative 1, our amplitude is going to stay a 1, but it's going to cause a transformation of a reflection over the x-axis since it's outside. So that's transformation 1. Transformation 2 is to move up 2. Notice here we've got multiple graphs now that we have multiple transformations. You're going to start with your original, then you're going to do transformation 1, then transformation 2. Put them in the order that you want. When there is a tie, just make sure that you have labeled which transformation you're doing in each section. So we start off with our original function, sine. So we graph line, or dot by dot, then connect by our lines. Start at the origin, on the upswing, connect with lines. Now that we're not sharing a graph, you're welcome to connect with the solid line so that you can clearly see what's going on, since we now know that the final graph is going to be our final answer. First step is to reflect over the x-axis. Anything on the x-axis is going to stay there. Anything above is now going to be below. Anything below is now going to be above. So each point is just going to be moved by reflecting it over that x-axis. Again, connect to make a nice smooth curve. The final step is going to move the graph up 2. So I just literally take each point and translate it up 2. Starting on that left side, moving to the right. Once you've translated everything up 2, again, connect with a nice smooth curve, and you'll have your final graph as your final answer. Okay, next example. We've got all kinds of things happening in this one, so we need to make sure we take good care of what's going on. We have an A value and a C value. That A is also negative, which is going to cause a reflection over the x-axis. The 4 is going to cause the amplitude to become a 4, that absolute value of A. Since there's no B, our period is going to stay 2 pi. Phase shift is going to be pi over 2 to the left because of the addition in the parentheses, and there is no vertical shift. So we reflect over the x-axis, we do a vertical stretch for that amplitude, times 4, and we move left pi over 2. Okay, so as we go to graph this, again, we start with the original. So cosine starts at its maximum on the axis, connect with a nice smooth curve. Start off with either the reflection or the stretch. I'm going to start with the reflection. I typically go left to right, but it would not matter which one you used. Each point's going to reflect over the x-axis. Anything on the x-axis is going to stay there. Again, connect with a nice smooth curve. Let's put it all together. Then we move on to the vertical stretch. Any y value that was at -1 is now going to be at -4. Any value that was at +1 is now going to be at +4. Repeat the pattern all the way across your graph. Connect the dots with a nice smooth curve to get your graph after an amplitude of 4. This third graph, by the way, if you had graphed in a separate order between number 2 and number 3, this third graph would have been the one that would match. So you would have done 1 here, you would have done 2 here, and then you would have matched in this graph. So the first graph would have been the same had you done these in backwards order, and the third graph would have been the same, and the fourth graph will be the same, which is after we move everything left pi over 2. So our point here at negative pi now becomes at -3 pi over 2. Our point at negative pi over 2 now becomes negative pi. Move everything left 1 unit, which is 1 pi over 2. Connect with a nice smooth curve, and you will get your final answer. Okay, our final example for the day is a big one. This is the big one. Okay, we've got 3 different letters represented here. We've got an A value, we've got a B value, we've got a C value. But before we determine what that C is, since we have both B and C, we need to make sure that we factor. So you're going to factor out the coefficient on x, which is -1/2. When you factor, you divide. So you've got an x left over. Because you factored out a negative, you're going to have a plus, and you're going to end up with 2 pi as your shift. So our amplitude, because of the 4 out front, is going to become a 4. Our period, we're going to have to calculate by doing 2 pi divided by the absolute value of B, which is going to get us 2 pi times 2, which is going to get us 4 pi, which, by the way, if you're paying attention to our graphs, is the entirety of our left to right space. Our phase shift is going to be left 2 pi, which is half of our whole graph, 2 pi, and we have no vertical shift. Transformations, we have a vertical stretch times 4. We have a reflection because of the negative over the y-axis because it's inside. We have a horizontal stretch times 2. Remember, it's the reciprocal of that b value, and then our last step we're going to do is going to be moving left 2 pi. If we start with our original, that's going to give us 5 graphs, which means we're not really going to end up needing the last one. Okay, so we use all of this and we start graphing a piece at a time. So start with your original cosine graph. Start with your dots connected so you get an idea of what it's going to look like. Nice smooth curve between them to show the cosine curve. Vertical stretch is going to come first as your first step. You're going to take every y value and multiply it by 4, which is going to move anything that was at a 1 up to a 4. Anything 0 stays a 0. Anything -1 becomes -4. Once you get the pattern, continue the wave and then connect with a nice smooth curve. Step 2 is the reflection over the y-axis. Because cosine is even, if I reflect it over the y-axis, it should look exactly the same. So this next graph is going to be the same graph as number 2 because cosine is even. Okay, had I reflected over the x-axis, that would have been a different story. I draw my points, I connect with a nice smooth line. I still make it a graph in my problem because I want to represent all of the transformations that I listed above. So I still perform that transformation over the y-axis, however, it's going to make the graph appear exactly the same. Step 3 is going to be the horizontal stretch times 2. Every x value is going to be multiplied times 2. 0 times 2 gets you 0. If you're left 1 unit, you now become left 2 units. If you're left 2 units, you now become left 4 units. Continue the pattern over on the other side. Right 1 unit is now going to become right 2 units. Right 2 units now becomes right 4 units. Very tempting when you just have this one curve to make it look like a V, but you need to make sure you're connecting it with a nice smooth curve to make it into the true cosine. Our final step is to move it left 2 pi. 2 pi is 4 spaces on our graph. So anything to the left is going to be absolutely gone. And that means our first point that we can move is that maximum on the y-axis, all the way left 4 units to -2 pi. Translate your pi to -pi. Translate your 2 pi to 0. And then continue the wave to finish the function. Once you've drawn all your points, connect them again with a nice smooth curve so that you can get that lovely cosine wave happening. And you will have your final graph for this function. We do not need the 6th graph space.